So we understand the continuity of a function at a point. What about the continuity of a function on an open interval, like on a whole interval, where it includes infinite many points? So the definitions is if a function f of x is continuous on an open interval from a to b, if it's continuous at all value of x in a to b, which makes sense, right? If it's continuous everywhere at all the values in the open interval from a to b, then we can call the function is continuous on open interval from a to b. And if you ask to determine the intervals, open intervals where the function is continuous, you can use the discontinuity that you found earlier in order to determine the intervals on which the function is continuous. So remember, there's three discontinuities. Those are x equals to -5, 0, and 4. Okay. Then you will draw a number line, -infinity to +infinity, and you plot the three discontinuity on this number line. And we know that the function is discontinuous at those points, which means you can cross them out. So these three discontinuities divide the whole number line into 4 different intervals. The first one from -infinity to -5. The second one from -5 to 0. Third one is from 0 to 4. And the fourth one is from 4 to +infinity. So the function f of x is continuous on these 4 intervals, and you can combine the 4 intervals together, using these notations, the union notations. This means combinations of these open intervals. Okay. Well, and then there's two kinds of continuity at a point. Even though at some points the function is discontinuous, but the function can be continuous to the left or to the right of that discontinuity. For an example, if we look at this point right here, the function is discontinuous at x equal to 0. However, if you look at 0 from the left, the limit of the function f of x when x goes to 0 from the left is the same as the function value when x equal to 0. So we say the limit of f of x when x goes to 0 from the left equals to f of 0. So if this condition is satisfied, then you can say that f of x is continuous from the left at 0. Or you can say that at x equal to 0, the function is left continuous at 0. X is left continuous at 0. Okay. It's not, f of x is not right continuous at 0 because the limit when x goes to 0 from the right is not the same as f of 0. So the formal definitions of left continuous or right continuous is right here. A function f of x is continuous from the right at b if the limit of f of x is the same as f of b. You can imagine that if you have function b here, function f's here, and this is b, right? And then the functions, the limit of the function f of x is equals to the limits go to here, and this point is also f of b. Then the functions is continuous from the right of b if this conditions satisfied. And we talked a little bit about the left continuous, right? A function is left continuous or continuous from the left at a if the limit when x goes to a from the left is the same as the function value f of a. And this is an example of left continuous. All right, so now you know how to determine which intervals the function is continuous by finding the discontinuities, divide the number lines using these discontinuities, and connect these intervals using the union notation. And then you can determine the left continuous or the right continuous using the left or the right limits, combining with the function values at that point.